fact that the grab module hatch still has to be good. It doesn't seem to be any different than any other legislative procedure in the past. There's no particular reason why our hatch is no better than other spacecraft.
Now the situation, Jim, is that your hatch is as good as any other hatch, but that we won't have a chance to verify it until so late in the game, like 1 hour before our entry interface in this case, whereas before we had a chance to evaluate it in lunar orbit. Over.
Oh, okay.
And that might make your timeline a little too crowded, getting your suits on there at the last minute. Say less than an hour before entry interface. Jim, the next action item we want to pursue is transferring some LEM power up to command module main B so we can start charging battery. And I guess what we ought to do is start on that when somebody else gets up to help you there. So when you decide to get the other guys up or to have someone help, why, you let us know and we'll start working on that.
Okay, yeah, I'd like to have Jack and Smith probably looking at that one. When in the timeline do you plan on doing this?
I'll say again, Jim, I didn't catch that.
When in our time, what ET do you plan on using this procedure?
Jim, I didn't catch all of what you said, but I think you wanted to know when the procedures for entry are going to be available and read up to you, and if that's the case, why, we're talking about 120 hours or so. As far as the charging battery A, we want to do that as soon as the other guys get up to help you. We've already passed up some of that procedure, and we have a couple deltas to it.
Roger, Jack's already up. He has the procedure, and I was just getting curious when you wanted to do it. But I understand that because he's done before. Is that correct?
Jim, we're having trouble hearing you. The next order of business is to charge battery A, and when you got somebody to help you there, well, we'll go get on with it.
Okay, sounds good.
And before you start working on it, let us know, because we've got some deltas to the battery charging procedure.
Roger, I'm getting Jack on the line now. Jack, go ahead.
Aquarius, do you call?
Yes, Jack, I'm on the line.
Okay, go ahead now. I can hear better.
Okay, Jack, Joe Kerwin passed me up the procedure for powering the CSM from the LEM. I have this gate.
Yeah, if you'll get that out, I'll read you the deltas.
Okay, I've got it.
Okay, the second step was in the LEM, circuit breakers panel 11 and 16, SN ECA controlled closed, 2 of them, cross that out. In the next line, we had battery 5 normal feed on. Cross out battery 5 and put battery 6 in there. And the next line was...
Jack, I had for step 3, I had bat 5 and bat 6 normal feed on. Just one bat 6?
That's affirmative, just bat 6, Jack. And the next line, you had battery 1 and 3. Make that battery 1, 2, 3, and 4. Just add bats 2 and 4, all 4 descent bats. And then the next 2 lines about waiting 30 minutes, cross that out. And the next line about batteries 2 and 4 off reset, cross that out too. And Jack, the...
let me read.
Go ahead.
Let me read all the steps I've got them, Jack, and make sure we got them right. Step 2 will now be bat 6, normal feed on. Step 3, bat 1, 2, 3, and 4, off reset.
Okay, that part's all right, Jack. And we had about 11 or 12 steps for the command module. They go as is with no change. And then we had a couple more procedures for the limb. Stand by one.
Okay, Jack, let me read the command module procedures just to make sure that I have them right also.
Okay, go ahead with the command module procedures.
Okay, connect limb CSM umbilical. Step 2, panel 5, TV, limb power, 1, main feed, and 2, main feed, close. Trigger breaker. Step 3, panel 5, GPS sensor signal, main feed, close. Step 4, panel 250, TV, battery, power entry, and post landing, close. Then step 5, main feed, back bus feed, close. Verify main bus voltage, then switch to limb power CSM. Step 7, TV, main feed, back bus feed, open. And on panel 250, bat feed, power entry, and post landing open. Verify main bus voltage.
Okay, Jack, the CSM procedure's okay, and then we had to go back to the limb and do something. And the first line is okay. Cross out bat 5 and 6 off. Delete that. And delete the next line also that says panel 11, 16, SN ECA control open. Then we had a couple of notes which remain the same. Go ahead.
Okay, I didn't get the notes, but I'll read the steps as I have them now. One step. Bat 1, 2, 3, and 4, high voltage on. So you'll have, at this point, you'll have batteries 1, 2, 3, 4, and 6 on. Is that correct?
That's affirmative. So now we've got bat 1, 2, 3, 4, and 6 on. And I've got 2 notes. Number 1 is circuit breaker protection limit. Your circuit breaker protection limits the current to 15 amps. Number 2 note is now the umbilical between a limb and a command module is hot. And the main bus voltage can be monitored by selecting main B.
Okay, Jack, these notes are circuit breaker protection limits current to 15 amps. Note 2, the umbilical between the CFM and lamp is hot. I can monitor main feed for the bus voltage.
That's affirmed, Jack.
Okay, Jack, one question here. If we transfer power like this, we're not going to cut it short on power remaining to get in the interface, are we? Just power remaining?
You'll have to say that again, Jack. I didn't get it.
Okay. Stand by. Okay. If we configure the CSM for powering from the lamp, we aren't going to cut us short on lamp power requirements to get us back to entry interface, are we?
That's a negative, Jack. According to the latest update, we've got ampere hours out to 203 hours.
Okay, Jack, one question from Jim is he wants to know whether the procedure has been tried.
Okay, try it again now, Jack. What does Jim want to know?
Okay, he would like to know whether this procedure has been tried and whether it has been found to be okay and no danger of shorting out any of our batteries or anything that we have on board the LEM now.
Okay, Jack, this procedure has not been tried out as such. However, the hardware paths through which the current flows are the same ones which we used during translunar trajectory, and there's not a problem with shorting out a descent battery, over.
Okay, I'll relay that to Jim.
Jack, of course, the reason for all this is that we'll see we're 20 amp hours short on one of the entry batteries, and we've got to juice that up to get you home with.
Okay.
Okay, now what we owe you from here on out is the actual battery A charge procedure, and then a procedure to turn this all around again. Okay, Jack, I have the procedure in front of me. It's about 18 steps, and the reason it's so long is because we're starting from this basic configuration which we gave you earlier, and it concerns a charge on battery A, of course, which is our low one. So when you're ready to copy it, let me know.
Okay, let's plan it.
Okay, you ready to read or copy it?
Plan.
Okay, on panel 250, circuit breaker bat A, power entry / post landing, close. On panel 275, circuit breaker inverter power 2 main B, close. Next several circuit breakers are on panel 5. Circuit breaker bat relay bus, bat A, close. Circuit breaker EPS sensor unit. AC bus 2, close. CB, EPS sensor signal. AC2, close. CB, battery charger. Main B, close. You still with me?
Okay, Jack, I'll read back those steps that you gave me so far. Panel 250, BB, Pat A, power, entry, and both landings, closed. Panel 75, CB, inverter power 2, AC, closed. Panel 5, CB, Pat QA bus, Pat A, closed. CB, EPS, sensor unit, closed. CB, EPS, sensor signal, AC2, closed. CB, fast charger, AC, closed.
Okay, good readback, Jack. The only one is number 1. Number 4, I didn't get your readback, but it's EPS sensor unit AC bus 2 closed. You got that?
Yes, I read that back. CB, EPS, sensor unit, AC bus 2, closed.
Okay, and to continue on the same panel, panel 5. Circuit breaker, battery charger, AC power, close. Circuit breaker, battery charger, bat A charge, close. Circuit breaker, inverter control 2, close. Circuit breaker, inverter control 3, close. And I got a switch for you. Main bus tie, bat A/C, off. And another switch, battery charge to AC2. Read those back.
Okay, Jack, CB, bat charger, DC power, closed. Stand by. Okay, I had to get a light here. CB, bat charger, bat A charge, closed. CB, inverter control 2, closed. CB, inverter control 3, closed. There's 2 switches. Main bus tie, bat AC, off. There's the second one, bat charger, AC2.
Okay, that's a good readback. How about reaching over there on the right-hand side and turning the biomed off? See if we can improve the comm a little bit.
Okay, how you reading now?
Okay, I'm reading real good now, and I want to verify that the main bus tie that we switched off was bat Alpha Charlie.
That's verified. Main bus tie, bat Alpha Charlie, off. And bat charger to AC2.
Okay, and then on panel 3, I got a switch for you. AC inverter 2 to main B.
Okay, AC inverter 2 to main B.
Okay, and switch inverter 2, AC bus 2 to on. And another switch, AC bus 2 reset to reset. and center. Switch battery charge to alpha. Switch DC indicator select bat charger. And then what we want you to do is to report the charger current and voltage to misspin every 10 minutes for the first half hour, and then once every 30 minutes after that. And that'll be on our call, Jack. Read back the switches I just gave you.
Okay, Jack, it's panel 3, AC inverter 2, main B. Inverter 2, AC bus 2 on. AC bus 2 reset. To reset and center. Bat charger to A. DC indicator select the bat charger. Report in and volt to misfit every 10 minutes for the first 30 minutes. And then every 30 minutes on misfit call.
Okay, that's a good readback, Jack. Now the only thing we owe you is a turnaround from this, which we will have.
Okay, let me ask one question here. About how long do you think it'll take to charge the battery?
It's going to take about 15 hours.
Jack, about how many amp hours of limp power will this 15 hours cost?
Stand by, we'll get it for you.
Jack? Okay, you got it. You got the question.
Okay, Jack, that's going to take 120 amp hours out of the limb, which is equivalent to 10 hours, which will put us back to 193 hours, and that's plenty.
Okay, let me relay that to Jim here. It'll take 120 amp hours. Which means put us back to 203 hours. 193 hours. Yeah, is that much fair? Okay, Jack, one question here. If we have any problem setting up this limb power to the CSM, is the quickest way to get out of it, return to the normal configuration, and for me to just switch the limb power to CSM to reset that off?
Stand by one.
I would like to get one quick step in case Jim reports some sort of problem for us to get out of it quickly.
Okay, let us talk it over for a minute, Jack.
Okay, real fine. And while you guys are talking it over, you might read back if you got the procedure for reversing this. I'll copy that. Jack, are you with me?
Yeah, we're still here, Jack. What we want to do is follow you through on this, and so we're going to get high bit rate to do it. In answer to your question, to undo this procedure quickly in the event a problem develops, be sure that you don't touch the limb power switch, because that's got a reset position. but the way to undo it is to go into the CSM and on panel 5, open 2 circuit breakers. And there's some of the first ones I read to you. Open LEM Power 1 main B and open LEM Power 2 main B. You copy that?
Okay, I understand. If I want to get out of this real quickly, I have to open just 2 circuit breakers in the CSM. It's on panel 5. LEM Power 1 main B, LEM Power 2 main B.
Okay, and before you go ahead with this, let's establish high bit rate and wait 1 on that. And then as we go through the procedure, we want you to wait when you get power on main B so that we can take a look at main B without any loads on it before we start charging the battery.
On the Lambert CSM, is that before we start this?
That'll be high bit rate on the LAM and stand by for it.
Okay.
Okay, Jack, before we go ahead with this, what we want to do is read you the normal reverse procedure.
Okay, and I'm ready to copy.
Okay, Jack, I got the start on how you reverse this procedure. You ready to copy it?
Go ahead, Jack.
Okay, first you want to reverse the battery charge procedure. To do that, on panel 3, switch, battery charge, off. AC inverter 2, off. Panel 5. Main bus tie, bat Alpha Charlie, on up. Panel 250, circuit breaker, bat Alpha, power entry in post landing, open, straight back.
Charger off, AC inverter 2 off, on panel 5, main bus tie, Alpha Charlie on, panel 250, CB, bat A, power entry and post landing open.
That's affirmative, Jack, and then if you'll go back to the rest of the circuit breakers on that list, and just opposite, open them all up. Stand by 1. Okay, Jack, go back to the battery charge procedure I gave you. And in order to terminate charge, you'll just have to write opener off next to the circuit breaker or switch that I gave you. So on panel 250, that circuit breaker you've already opened. On panel 275, inverter power 2 main B, open. Panel 5, bat relay bus bat A, open. EPS sensor unit AC bus 2, open. EPS sensor signal AC2, open. Battery charger main B, open. Battery charger AC power, open. Battery charger bat A charge, open. Inverter control 2, open. Inverter control 3, open. You've already done the main bus tie. And then bat charge, switch to AC1. Over on panel 3, 3. You have already set the AC inverter 2 to off, and then inverter 2 AC bus 2 off, AC bus 2 reset to off. You have already put the battery charger switch to off, and your DC indicator select to main B. Over.
Okay, Jack, do you want me to read it back to you?
No, if you've got something in the right-hand column for all of those, we won't have to do it. And now one more thing I owe you is how to untransfer LEM power to the CSM. And I'll get that for you in a jiffy.
Okay, I'll be standing by to copy it.
Okay, we have last minute change to that.
This is Apollo Control at 111 hours 30 minutes. The procedure being read up to the crew by Capcom Jack Lausma is for recharging one of the 3 entry batteries on the command module, battery A, which is down about 20 amp hours. A full load on the entry batteries is nominally about 40 amp hours. We understand the other 2 batteries, B and C, are essentially fully charged. Battery A is down about 20 amp hours, and the plan is to replace the energy in the command module, battery A, with electrical energy from the lunar module. This procedure will require about 15 hours of charging time and will draw a total of about 8 amps from the LEM.
High bit rate. They're going to get high bit rate on the LEM. They're going to be watching. I don't think the empty very But I just want you to think out how clear is tell me to take power off, and I'll get some pictures that they gave me out right away. And also, I won't have the ground get getting close to yellow. I don't think we won't have any white power. Jack, one thing that I guess you probably all have considered it, but what heavy things can we store down there where the SRCs normally go to help increase our L over D?
I understand the question is what kind of heavy things can you store where the SRCs go?
Yes, they go down there in the LED underneath the computer, and the heavier things you have down there increases the L over D. And we don't have any SRCs, so I just wondered what heavy things. We could probably put some cameras, television cameras, things like that that are normally pretty heavy down there that in an SRC, which no, we can't put them in an SRC, but we put them in that container down there, which would help increase our L over D. Anything else you could think of be greatly appreciated, because we don't even have a full weight tank, so we're down a little bit in L over D.
Okay, let me pass that question along and get somebody working on it. Souvenirs, I guess.
What souvenirs? All I've got is the Marine Corps foxhole digging shovel.
You got all you need then, buddy. Okay, ready to copy the power removal from the command module LEM umbilical.
I'm ready to copy. Go ahead.
Okay, this assumes that all the descent batteries are online and ascent battery 6 is on normal feed, as we said earlier. First thing you do is go in the CSM and look on panel 5, circuit breaker. LEM power 2, main B, open. LEM power 1, main A, open. Circuit breaker, EPS sensor signal, main B, open. Go ahead.
You got a little bit scratchy there because of the antenna problem. I think that's go back here. Okay, what I got, Jack, was the procedure assumes that all descent batteries are on and bat 6 is on normal feed. Now we go into the LEM, and on panel 5 we take LEM, or CB, LEM power 2 main B open. And that's as far as I got here.
Okay, the second one is on panel 5 also. Circuit breaker, LEM power 1, main A, open. Circuit breaker, EPS sensor signal, main B, open. Okay, read those back with the CSM and I'll give you some steps in the LEM.
Okay, CB LEM power 2 main B open, CB LEM power 1 main A open, CB EPS sensor signal main B open. And stand by 1 here. Jack, I don't think we ever closed CB LEM power 1 main A. We closed LEM power 2 main B and LEM power 1 main B. Both of them on main B.
Yeah, you're right. Both of them should be main B.
Okay, copy that.
Okay, ready to copy the limb?
Okay, go ahead.
Okay, on panel 16, circuit breaker, EPS, bat feed ties, 2, open. And now you got to listen real carefully for high volts and low volts. Battery 1, high volts to off reset. Battery 2, low volts to off reset and then on. Battery 2, high volts to off reset and then on. Battery 1, high volts, on. And then a circuit breaker on panel 16, EPS. Bat feed ties, both of them, close. Read back.
Okay. On the left side of the house is on panel 16, CB, EPS, bat feed ties, 2, open. Battery 1, high voltage, off reset. Battery 2, low voltage, off reset, then on. Battery 2, high voltage, off reset, then on. Battery 1, high voltage, on. Then on panel 16, CB, bat feed ties, 2, close.
Okay, that's a good read back. That concludes the procedure going both ways, and now we just have to stand by.
Okay, when do you plan to start this?
Darn soon.
You say not soon?
We're going to do it pretty soon, but we want to have high bit rate, and we don't want you to give that to us until we tell you.
Okay. I think I'll go back and try to damp a bit. Do you have anything more for the command module?
We're discussing 2 items, but we don't have them ready right now.
One of them, I hope, is a foolproof alignment procedure. And Jack, just for curiosity's sake, Fido have any information as to whether that helium, that sea tank dump affected our trajectory at all?
Okay, Aquarius, our tracking data shows that since the helium dump, our entry angle has not changed from its value of 6.24. And somebody calculated that if we had a propulsive vent, that helium could roughly at the maximum only impart delta V of half a foot per second or less anyway. But we're continuing to track, and as soon as we get some more info, we'll pass it along.
Okay, be that well, Jack. Thank you.
Sure.
If 6.24 sounds good. Predict the continued performance back out down there.
Okay, Aquarius, we're ready. So we want some high bit rate. To do that, go over to panel 16 under COM and enclose the primary S-band power amplifier on your COM panel.
Okay, okay, Jack, wait one while I'd like to get the whole crew up for this, if you don't mind.
Okay.
They're ready to start. Yeah, you want to get Fredo? I want to transfer some power. I want to go to high bit rate here first, and then want to transfer put the left power to CSM strip. Okay, Jim, I'll give you the comm.
Aquarius, there's no great big rush. If you want to let Fred come up to speed slowly, why, maybe that'll help out. Say again, Jim. Aquarius, how do you read?
Loud and clear.
Okay, I'm hearing you now. I think I missed your last transmission, Jim.
Oh, okay. Jack is showing to Fred the procedures. Wants to get him familiarized with them and how to get out of any problems before we proceed.
Roger, no rush. Just let us know when you're ready. We don't want old Fredo to slip a gimbal there.
Yeah, we're watching them. Wait, if you take 120 hours out. Oh. Yeah. Okay. Untitled what? Yeah. Houston, Aquarius.
Hello, Fred. Go ahead.
Okay, I guess the only question I have is in the very first portion involving the limb here, where it has me turn on only bat 6 and then turn off all the descent bats. Are you still reading me?
Okay, I read you until after turn off bat 6. Or correction, turn on only bat 6.
Okay, the question is, we only want one acid battery, bat 6 on the line, immediately followed by turning off 4 decent bats. Is that correct?
affirmative, Fred. That question's been bandied around, and we decided to go that way.
We'll be powered at other bus via the cross-side balance flow breaker. Is that correct?
That's affirmative, and we're reading a current of 11 amps right now.
Okay. Okay, I guess I'm ready.
And
11 amps?
after you turn bat 6 on a line, we might as well take a look at the bats 1 through 4 and so forth, make sure it's okay to turn them off.
All right. Are you ready, gang?
Yeah, we're ready for the power amplifier and the high bit rate and normal voice on the function switch, please.
Okay.
Okay, gang, we got the high bit rate now.
All right.
Okay, we see bat 6 on, and it looks good, Fredo.
Okay, am I cleared to proceed with the next step? Get 1, 2, 3, and 4 off reset.
Affirmative, you're cleared for bats 1 through 4 off reset.
Okay.
Okay, still looks good.
Okay, in Houston, we need a call from you when to have Jack proceed up into the up in the Odyssey and start up there.
Okay, Aquarius, Jack can get with it right now.
Okay. Okay, Houston, Aquarius, we've completed the power up and things look good upstairs. So we go for proceeding with battery charge.
Okay, Aquarius, you're going to battery charge.
Roger. Boy, this is really a switch, isn't it, Jack?
That's an understatement. You're not known for that.
Yeah, I think if you add up the, operating time, I think the LIM beats the CSM by a considerable margin on this flight.
Grumman just hired you.
Yeah.
You're out there at 134,000, coming in at about 4,900 feet a second.
Very good.
The supercrit tank went off at 1937, just about like expected.
Yeah, it also must have not did very much except the rates. I was asleep then and I didn't hear a thing.
Is the command or service module still venting?
just before he went up. Right now the sun's over there and I can't really tell.
And
I'll look again in a minute.
we asked him a long time ago if he was able to see any stars out the optics. I don't think we ever got an answer.
Okay. That was a pretty good sleep station I had rigged up, Jack. I took one of the sleep restraints out of the command module, zipped up in it, and then hooked the tie right at the top of the zipper onto the LEM upper hatch handle. So it kind of held me there, and then just drifted up in the tunnel upside down with my face toward the hatch. So the sunlight didn't get my eyes, and that worked pretty good.
Did you sleep pretty well that way?
Yeah, no problem at all.
That's Fred Hayes talking.
That way now, or is he standing next to you?
He's standing next to me.
About time for him to go to bed.
Okay, the voltage upstairs is 34.3, and the charger is reading 2.5 amps.
Okay, 34.3 and 2.5. And ECOM says that's what you expect.
Pretty cold. Good.
Say again your last?
And they both came down here rubbing their hands, shivering. It's pretty cool upstairs.
Are you keeping warm in the LEM?
Yeah, it's pretty reasonable down here. Right now, it looks like the command module is spinning, Jack, so I'm going to try to take a look at the optics.
Okay, did you say it is not venting?
Yep, that's the word. We just looked through the AOC, and it can't see anything back there.
Okay, and everything's fine in El Lago.
Very good. Okay. Houston, Aquarius, any read?
I'm hearing you with a lot of background noise, Trevor.
Okay, I know. I just switched off the again.
This is Apollo Control at 112 hours, 18 minutes. The crew at this point has successfully completed the transfer of power from the LEM onto the command module main bus B, and from there into the battery charger, which is charging battery A, one of the three entry batteries used for entry and post-landing electrical power aboard the command module. The hope is to bring this battery from its current level of 20 amp hours up to about 40 amp hours, which would be essentially a full charge on battery A. The other two batteries, batteries B and C, already being at full charge. The charging operation on battery A is expected to require about 15 hours, and it began at 112 hours, 12 minutes ground elapsed time. You heard Fred Hayes report that Jim Lovell and Jack Swigert had gone into the command module to power up the battery charger and check on the readings there. When they came back down, Fred said they were rubbing their hands and noted that it was a bit chilly in the command module. At the present time, Apollo 13 is 133,158 nautical miles from Earth, and the spacecraft velocity is up now to 4,891 feet per second. We're 30 hours, 20 minutes, 50 seconds from re-entry. And according to the at 112 hours. The 3 crewmen should be getting something to eat. And also you heard Capcom Jack Lausma advise Jim Lovell that it appeared to be about time for him to get a bit of rest. The crew rest cycle has been left pretty much up to them. Our flight plan on one of the large displays here in Mission Control has some suggested times for sleep, but the crew has generally been working out their own sleep schedules as convenient for them and following it. And we don't have an extremely good idea of when they plan to in advance, but only after the fact when they report to us that they have gotten some sleep. At 112 hours, 21 minutes, this is Apollo Control, Houston.
Aquarius, could you get a amps and volts readout from Odyssey, please?
Okay, stand by. DMP is dotting across there. You're amazed at how proficient you get it transferred to the tunnel after the first 1,000 passes.
I didn't get your last there, Fredo. We'd like you to verify that your power amplifier circuit breaker is open.
Okay, that's verified. The power amp breaker is open.
Roger.
Okay, Jack is 34.6 volts and just close bit under 2.5 amps.
Okay, Fredo, copy 2.5 amps. Say again the volts, please.
34.3, and that was just a little bit below 2.5.
34.3, thank you.
Okay, correct. Voltage now is 34.6. Going the right way.
Fredo, I did copy your last. Say again the voltage, please.
Okay, and the voltage is 34.6. 34.6 amps, slightly less than 2.5.
34.6 and a little below 2.5. Thank you.
Yeah, the way we're contorting around the sky here, Jack, we're hitting some intervals here where I can't hardly get to it either on me. Houston Aquarius.
Go ahead, Houston Aquarius.
Okay, Jack reports from upstairs that he can see stars and constellations out of the optics, and the sun angle is such that it is reflecting off of a limb, portion of a limb quad, and one other stuff that happens to be in the field of view right now.
Okay, the part that I got was that he can see stars and constellations, and there's some sunlight reflected off the quads. That's all I got.
Yeah, the point being that at least in their present orientation, he has to kind of wait till the sun isn't reflecting off of the limb to see him.
Okay, what you're saying is you kind of have to wait until there's no sun reflection on the limb to see the stars. Is that right?
Yeah, that's for their present orientation, of course. Later on, you can probably move it around and even look at something and maybe pick up stars. I don't know.
Okay. Okay, Fredo, and we need a volts and amps reading.
Bring it back upstairs. The volt, 35.0 and 2.4.
Okay, 35.0 and 2.4. Thanks, Fred. prediction for your landing area is still good. 2,000 scattered, high scattered, 4-foot seas, 15 knots wind. There's a hurricane 500 miles to the west, which doesn't pose a problem.
Hurricane or typhoon?
Delay my last and be ready to accomplish. Aquarius Houston, we need another readout, amps and volts, and that'll be our last one for a half hour. Over.
Okay, the reading is 37.8 volts, 2.3 amps.
Say again, Fred?
37.8 volts, 2.3 amps.
37.8 and 2.3, and that'll be our last one for a half hour. Thank you. And I'm about to exercise my 5th general order here and pass it along to Joe.
Yeah, it must be getting around a hill then.
This is Apollo Control at 112 hours 50 minutes. We're in the process of a shift handover at the present time in Mission Control. Flight Director Glenn Lunny is replacing Flight Director Milton Windler. The capsule communicator on the upcoming shift will be astronaut Joe Kerwin. At the present time, Apollo 13 is 131,712 nautical miles from Earth. The spacecraft velocity is up now to 4,928 feet per second. Repeating a figure passed along a little while ago, the flight dynamics officer reports that as a result of the mid-course correction, the flight path angle at entry is within the entry corridor. The flight path angle currently appears to be minus 6.24 degrees at entry interface. The nominal flight path angle is 6.5, and that is what the mid-course correction was targeted for. 6.24, a negative 6.24 degrees is within the entry corridor, and a decision has not been made at this time as to whether any subsequent mid-course corrections will be required. At 112 hours 51 minutes, this is Mission Control, Houston. This is Apollo Control at 112 hours 55 minutes. ECOM, the command module electrical and environmental control engineer, reported that the power transfer to the command module main bus B is continuing to function smoothly, and the battery charging operation also progressing well at this time. Battery A, one of 3 entry batteries aboard the command module, is being recharged. and EECOM reports that it appears to be taking a charge well. At 112 hours 56 minutes, Apollo 13 is 131,426 nautical miles from Earth, traveling at a speed of 4,935 feet per second. And we're now 29 hours 44 minutes from re-entry.